Howdy. Today's video will cover transformations. Now, what is a transformation? A transformation is manipulating the parent function, causing it to move around the coordinate plane. And we will be using function notation for this, so using f of x instead of y. F of x stands for the function of x. So usually when it comes to transforming functions, we usually do the quadratic function, f of x equals x squared. Now, make sure that you know what the points are of this function, because the points are what we transform around the graph. So 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Okay, so let's go ahead and write those out. So the points that are important for transformations are 0, 0, plus and minus 1, 1, plus and minus 2, 4, plus and minus 3, 9. These points are what we're going to move around the graph. And that's the point of transformations. So getting started, at first glance, this graph is different from our parent function. Our parent function starts at 0, 0, but this one has moved up 1, 2, 3 units. Okay? So start the graph of x squared plus 3. X squared plus 3 is your graph. And this is 3 units higher than the basic quadratic function, f of x equals x squared. So that is x squared plus 3 is f of x plus 3. Because what we have here, we have f of x plus 3 equals x squared plus 3. Because usually we have f of x equals x squared. All we did was add 3 to the outside of it. And it shifted the graph up 3 units. So we added a 3 outside the function, blah, blah, blah. Okay, so moving a function up and down. Moving up, to move a function up, you add outside the function. F of x plus b is f of x moved up b units. Moving down, to move a function down, you subtract outside the function. F of x minus b is f of x moved down b units. So continuing, now we have a function that looks like our parent function, but it's moved left 1, 2, 3 units. Okay, so this is going to be the x plus 3 squared graph. Okay, so what we did, we added 3 to the inside of your function. And that would move your graph left 3 units. So we have f of x plus 3. See how we added 3 to the inside of your function notation? And that gave us x plus 3 squared. So x plus 3, x plus 3. Okay, and then the above equation is f of x shifted 3 units to the left. Correct. Okay, now moving left and right. Moving left, to move a function left, add inside the function's arguments. So f of x plus b is f of x moved left b units. Moving right, to move a function right, subtract inside the function's arguments. So f of x minus b is f of x moved right b units. Now, don't forget, left is adding, right is subtracting. That's the total opposite of what you think, because when you think of adding something, you think of going to the right, because adding is positive, the right side is positive. But it's the opposite for this. Left is adding, right is minus. Okay? So here's another warning. Do not be tempted to move the function right by adding. Okay? Moving left and right is opposite of moving up and down. We have another thing called stretching and compressing, or elongated or shortening. Elongating and stretching. To elongate the graph, multiply to the outside of the function. So a times f of x, where a is greater than 1, is stretched along the x-axis. Shortening or compressing is multiplying by a, so multiplying by a, but where a is in between 0 and 1, and it's going to be compressed, or it's going to be, compressed along the x-axis. Okay. Now last and easy transformations. As you see here, we have a graph, and it's flipped upside down. What? Yeah, flipped upside down. So this one, if you have a negative on the outside of your function, so negative x squared is this function here. That means it's going to flip across the x-axis, or reflect across the x-axis, or just flip upside down, whatever, however you want to call it. But any points on the x-axis stay on the x-axis, and all points not touching the x-axis switch sides. If they're on top, they go to the bottom. If they're on bottom, they go to top. So reflecting the function across the x-axis and y-axis. To reflect the function across the x-axis, switch the function sign. So the sign outside of the function here means reflect across the x-axis. Now, reflecting across the y-axis, we switch the argument sign, so inside. So when you have a negative on the inside, it's going to reflect across the y-axis. And then here's our only example. We have our f of x equals x squared, which we're going to graph, and then we have negative f of x minus 2 plus 3. So let's go ahead and label this right here. And the negative means flipped across, the negative on the outside. Look at your notes, it means flipped across the x-axis. This negative 2 on the inside means shifted or translated right 2 units. And this positive 3 shifted up 3 units. So we're going to be shifting our parent function f of x equals x squared. And the points that we use for that, remember, is going to be 0, 0, 1, 1, 2, 4, 3, 9, which can't fit, so negative 1, 1, 2, 4. Okay, so these points here are the points of f of x equals x squared. Okay, I didn't just randomly choose these. This is your function right here of x squared. And what we're going to do with our transformation here is move all these points the way that this translation here tells us to. Okay? So starting with your 0, 0 point, you're first going to flip across the x-axis. So since it's on the x-axis, it will stay on the x-axis. And then you're going to look to the right, shifted right 2 units. So you're going to move this point here, right 2 units, 1, 2. And then you're going to shift it up 3 units, 1, 2, 3, right there. Now look at your 1, 1 points right here. It's going to flip across the x-axis. So since it's at 1, 1, it'll now be at 1, negative 1. And then it's going to shift right 2 units, 1, 2. And now it's going to shift up 3 units, 1, 2, 3. And then the 2, 4 point is going to reflect across the x-axis. Shift 2 units to the right, and then up 3. And that is one side of your graph. And now the other side is going to be right here and here. So that is the reflection. Okay, so not too difficult. All we're doing, just remind yourself, all we're doing is moving points on a graph. That's all we're doing. We're not multiplying by anything. We're not subtracting anything. We're looking at a transformation, and we're deciding where the old points are going to move to the new points. Okay? So that's all, guys. Thanks for watching. Don't forget to do your worksheets, your notes, etc. Bye.